negations. Okay? That's the first law. And the second one, the negation of the conjunction is equivalent to what? Yes?
The disjunction of the negation.
Exactly. So it's the other way around. Okay? Now I would like you to show, I would like to show you that actually that is true, and you can see this. Okay, so let me just give you an example for that to demonstrate that this is true, because that doesn't sound intuitive. Okay? Sometimes people mix it up, you know, and they make like statements which are actually completely, nonsense. I don't want to say bullshit, but I almost did anyway. Okay, so for instance, let's say that you have statement A and statement B. Okay, so these are the combinations. Okay, so I'm going to give you the truth values, and the four combinations are, let's say, suppose that statement A is true, and suppose that statement B is also true. Okay, then what? Then we look at the, we look at the disjunction first. So disjunction is also true, obviously. And what about the negation of the disjunction then? What about the negation of the disjunction in that case? So if the disjunction is true, then its negation is what? Is what? Yeah, false. It's false, obviously. Okay, good. Obviously. Okay, I need more space, so it's not wrong what I've written, but I need a little more space here, guys. Okay, so let me just try it again. It was correct. I'm going to write it again, but I need more space because I'm going to put it actually on the same page. So suppose that both statements are true. Okay, then the disjunction of the statement is true, and the negation of the disjunction is going to be false, obviously. Now, guys, if the statements are true, what about their negations? What about the negation of A? If A is true, then what? The negation is obviously false. All right. And the negation of B is what? Is also false. Okay. And what about the conjunction of the two negations? So if two statements are false, then the negation is also false. All right. Okay. So let's finish this up. So then you see. Okay. Here there is a parenthesis missing. Okay. All right, guys. Let's continue. Suppose that statement A is true, and suppose that statement B is false. Then what about the disjunction of the two? Is true. What about the negation of the disjunction? Is false. There you go. What about the negation of the statement A? If A is true, then the negation is what? False. There you go. What about the negation of B? If B is false, is true. That's right. And if one statement is true and the other one is false, what about the conjunction of the two statements? False. Okay. Okay, so let's finish it off quick, and then you see. So suppose that statement A is false. Suppose that statement B is true. Okay, what about A or B?
True.
Yes. What about its negation? Okay, it's false. If statement A is false, then its negation is true. If statement B is true, then its negation is false. And what about if, let's say, two statements, one statement is true and the other one is false, then the conjunction of the two is going to be false. All right. You get that? And the last one, if both statements are false, A and B are false, then the disjunction of the two is also false. Then you have that the negation of the disjunction is going to be true, obviously. And then the negations of the statements are going to be true as well. So here in that case, the negation of A and negation of B is going to be true. Okay, because both statements are true. Now, guys, I've said that two statements are equivalent if they have the same truth tables. Sorry. And this is what you have here. You can see this clearly. So this statement here, I mean, depending on assuming that you have the same input argument, okay, has exactly the same truth table as the other one. Okay, so this is actually how you demonstrate that the first law of De Morgan is going to be actually true. All right, because the truth tables of the corresponding statements were true, obviously. All right. Okay. I don't want to show the second one. Maybe you can do this as an exercise if you like. Okay. Okay. So this is actually how you demonstrate that the first law is true. Okay. The outcome is always the same. Okay, depending on giving the input. All right. Good. Okay, guys. So maybe you can, just an example, maybe you can look at the example number 1. Okay. If you don't have it here, then I would like you to give you just an illustration, short illustration for that. So that might be actually an assignment that you need to solve. Okay. So for instance, I mean, let me just write it down. So suppose that the following statement is true, and if you don't have it here, I'm just going to demonstrate that. Okay. So how to apply this? Okay, so suppose that this refers to actually to logical intelligence, guys. Okay, so if you do this correctly, then you will not make any mistake in terms of logic. Okay, sometimes when you apply for a job, okay, you have to perform a test first in online most cases, and it's actually for a certain duration is given, I don't know, like 10 to 15 minutes or something in most cases. And these tests involve certain logical skills, you know, so the firms would like you to examine, and they use examples like these, okay? So if you perform that correctly, you will not make any mistake, and then people like, oh, you know, wow, who is this coming, or whatever, okay? So this is, you get 100% score if you do this correctly, okay? So that's why we're doing this. I mean, do not assume that there is no practical reference to that. I mean, think of it when you get, you know, you're invited to a job interview, but you're supposed to actually perform a test first, and you're supposed to pass the test, you know, in terms of logical intelligence. Okay, so you get 100% score. People are gonna be like, okay, you know, this guy is a genius or whatever. Okay, right. So anyway, okay. So I would like you to show. I mean, this is. Let's suppose that the following statement is true. Okay, so suppose that anyone. And this is what the example says. Who is related to, there is, you know, a woman called Paula, whatever, I call it just P. Okay, so anyone who's related to P is also related to Simon, but not to Emily. Okay? So just I'm referring to capital S, but not to person capital E. All right, and suppose that this is true, and there are actually 3 statements, and you have to select those that are true. Okay, all right. So let's do this. Maybe you can see this clearly. Okay, so how would you actually write it down in terms of the formal notation? I mean, I explained this in an example, but you can use the following. So suppose that, you know, P denotes the statement that someone is related to P. Okay, so if that statement is true, that means that, you know, the person that we're talking about is related to P. Okay, so, you know, a given person. So this is what I do. A given person is related to Paula. Okay, and for the other ones, analogously. Okay, so I'm not going to write it down. So if you write, let's say, small c, then this statement holds true. Yeah. Then this person is related to Simon. And okay, so for the remaining people, analogously. Okay, so how would you actually express this in terms of logic? Okay, so if someone is related to Paula, okay, so if statement P is true, then what? Then what you have is. So this implies that what? That S? Yes?
And not E.
Okay, exactly. Okay. Alright. So this statement is supposed to be true here. This is what is given. Okay? So this is what is given. This is the given statement. Alright? Now using that, you have to examine whether or not the following statements are true. So for instance, the first one is anyone who is related to Simon but not to Emily is related to Paula. Is this true or false? Okay, let me just use that. Okay, so true or false, okay, and this is going to be it, so true or false. Okay, and maybe these are the things that you're supposed to select from. So anyone who is related to Simon but not to Emily is related to P. Okay? I put this in quotation marks. Okay? Now, is this statement true or false? So suppose that this is going to be like, you have an assessment center and you perform, you have to fill out this test online and you have to pass. Would you consider that statement to be true, or would you consider that statement to be false? What do you say? Yes?
As being related to S but not to E is necessary for P but not sufficient.
Exactly.
This is not
That's what we're talking about. So if that statement was true, guys, okay, then this statement would be necessary, would be sufficient for this one. But this is not the case, because it's only given that it is necessary. And just because a statement is necessary for another, it does not imply that it's also sufficient. You understand that? Okay? So actually they want to turn this around and say, okay, if A implies B, does also B implies A. Okay? And that is not the case, guys. So if a statement is necessary for another, then it does not imply that the statement is also sufficient for the other. Okay? All right? So this statement here, and which is obvious here, is false, and you find this. Okay, so this statement is false. Okay? So please do not consider that to be true. All right? Do you get the point? Okay? Okay, next. So you have anyone who is related to Simon but not to Emily is not related to Paula. Okay, so this actually would be, I mean, maybe I can use this so you see this clearly. So this statement says, all right, so that if, okay, so let me just demonstrate this again. So this is what we're talking about here. So if this statement is true, that this shall imply that P is true, which is false. Okay, so that statement is false. Please keep that in mind. Okay, I'm writing it like I'm using this here, this notation. So that statement is false. Okay, because that statement here does not imply P. Okay, it's only necessary but not sufficient, guys. Okay. Now the next statement here is, or I mean, you're supposed to examine anyone who is related to Simon but not to Emily is not related to Paula. Okay, so here in this case, anyone, who is related to Simon, to S, but not to E, is not related to P. Okay? So the only difference between the two is that here, in this case, that this statement shall imply that this is not true. Okay? Okay, so the statement says the following. It claims, okay, so it claims that, and let me just give it to you, just a formal notation, so that this statement should be necessary for this one. You understand? So this is the claim. Okay? Now guys, let me just tell you one thing. This statement is also false. Okay? It doesn't mean that the person that we're talking about cannot be related to Paula. Okay? But it means that here in this case, that just because someone is related to Simon but not to Emily, it does not imply that this person is not related to Paula, because that person can be related to Paula. And why is that? Okay? let me just give you actually the reason for that, why that is. Okay? So what is given, this is the given statement here. Okay? So this is the given statement, and this is equivalent to what? According to actually the first lemma that we introduced. Okay? This is equivalent to what? This is equivalent to, and let me continue over here, that if this statement is not true, then this statement cannot be true either. Okay, so if the negation of this statement is not true, then the negation of the other statement is not true either. So here you see that only, and you can see this here, the negation of the statement implies the negation of P, but not the statement S and not E itself. You understand? Okay? So if you say that someone who is not related to Paula, so not related to Simon and not to Emily, or Emily, sorry, then you can imply that this person is not related to Paula, but not just from the fact that someone is related to S but not to Emily. Okay, so in that case, you could not imply this. Do you understand this, guys? Okay, so this statement shall be actually sufficient for that one, but not this one. So this is actually nowhere here, so that statement is false.
Sorry, do you need two equivalence symbols, or?
These two are equivalent. Okay, so
yeah, but you have to write both of them.
I mean, you're supposed to actually.
Okay.
Okay, so you're supposed to. I mean, you have this one. This is equivalent to that one. Okay, so this is what I mean. Okay, you don't need to write it twice. No.
Ah, okay.
Okay, so
yeah.
once is enough. But I would like you to make sure that this is where it just continues. Okay. All right. So this statement is false. You cannot imply that. Okay. Let's continue, guys. Okay. So what about the next one? Okay. Do you understand this? Okay. So this is how it works, and the third one, which is claimed to be true, is this: anyone who is related to both Simon and Emily cannot be related to Paula. Okay? Okay? Good. Now what does it mean? Okay, so suppose that someone is related to both S and E. Okay, so in this case, suppose that this is true. Okay? If someone is related to both, then what? And this person, okay, and which is also obviously true. Okay, so here you can see this here. Then this person is related to Emily as well. Okay? So if someone is related to both, then this person is also related to Emily. Okay, so that is sufficient, guys. Okay? If someone is related to Emily, okay, then this implies, on the other hand, okay, that the corresponding person is related to Emily or not to S. This is also an implication that you can make. So for instance, if a statement is true, then the disjunction of any other statement is also true. Okay? You understand? Okay? Is this clear? Alright? Not the other way around, but if, let's say, a statement E is true, then the disjunction of any other statement with the statement D is also true. Okay? Now this is equivalent, according to the lemma that we will apply here in the previous section. This is according to de Morgan's law, and you maybe remember this. Okay? So if I want to perform actually negation of this, so you have the negation of S and not E. Okay? So this is actually what you're going to get from de Morgan's law. Okay? And we find out actually in the first section, okay? No, it was the second one. And this is what the statement what we have here is that if somebody satisfies this condition, that this implies that statement P is not true. Okay? So here in that case, we find that someone who is related to both to S and to E cannot be related to P. Okay, so therefore this statement is true. Okay? Okay, so this is, and that is actually how you prove it. Okay? So all I did was applying these rules no matter what. Okay? Maybe I would like you to add something here to that, because that might not be actually something that you might consider. Okay, so maybe just let me add just 1 or 2 remarks. Okay, so suppose that if a statement A is true, then the disjunction of any other statement is also true, no matter what. So if statement A is satisfied, then the disjunction is also satisfied. And on the other hand, if you have the conjunction of the statements, then you can imply that any of the statements also must be satisfied. So if both statements are true, then at least one of the statements must be true. Okay, so A must be true if A and B are true. Okay, because if A is not true, then actually the conjunction cannot be true either. And I can apply this to any other statement, guys. Okay, is this something that you are aware of? Okay, so this is what I used actually in addition to that, because I see, okay, if let's say 2 statements are true, then actually, you know, S and E, then E must be true as well. This is an implication that I can make. It's also true for statement S, but if, let's say, someone is related to to both people, S and E, then he or she is also related to E, no matter what. Okay? And that statement is also an implication which is true at all times. Okay? So anyone, actually, basically, we find, okay, so anyone that, okay, apologize, I don't want to mix this up here. Okay? So anyone who is related to both people, okay, here, cannot be related to Paula, given that actually the original statement is true. Okay? Is this clear? Okay, now this is what you shall apply. Okay? I want to finish it here, and next time we're going to continue with the next topic. Okay? Because I need to get to another campus, and I'm sorry for not being able to answer your individual questions. So if you have individual questions, guys, please save them for next Friday. Okay? Because I have to leave. Otherwise, if you have general question, would you like to ask anybody? Yes?
Will the next lesson will be recorded? Recorded as well?
It will be also recorded as
okay.
well, so if you miss a lecture, you can follow this online. Okay?
Because I have a mentor tutorial.
Don't worry if you cannot attend, but the problem is that I need, let's say, 1 or 2 days to upload the videos. I mean, these are high quality videos, let's say 6 to 8 GB or something. And it takes at least 1 or 2 days if I have like 2 videos that I should upload. And I also need the camera for something else, so I'm also uploading other courses in parallel. Okay, so sometimes you might miss that. Okay, but please make sure that you actually follow these lectures and after that. So this is what I'd like to recommend. Okay, guys. So next time we're gonna continue with the next subject, and the first assignment will be about this. Okay, thank you.
Assignment to down